Cooperative multi-agent reinforcement learning faces a brutal trade-off. Explore enough to discover rare coordination strategies, but not so much that you drown out the task signal. The standard fix is intrinsic motivation, adding a novelty bonus scaled by a hyperparameter beta. But beta is notoriously unstable. Fix it too high, and noisy exploration collapses the team. Fix it too low, and you never find the solution. Plus, different agents generate novelty signals of wildly different reliability. Recent research solves this with a dual-layer scheduling system. First, a return-conditioned beta schedule. Instead of a fixed value, beta is dynamically adjusted using a sigmoid function driven by the team's exponential moving average return. Early in training, beta sits at its maximum, pushing aggressive exploration. As returns climb, the sigmoid smoothly decays beta toward a minimum, shifting focus to exploitation. This feedback loop is mathematically proven to converge under standard contraction conditions. But global scheduling isn't enough. The second layer is reward signal quality, or RSQ. The framework treats each agent's intrinsic reward like a noisy communication channel and calculates its signal-to-noise ratio. Instead of exact water filling, the method uses a clip-defined modulation that guarantees higher SNR agents always receive more budget, avoiding the irreversible suppression that crashes training on narrow corridors. Agents in open space generate consistent, high SNR signals, so RSQ amplifies their budget. Agents stuck in bottlenecks or overly dependent on teammates produce noisy, fluctuating signals. RSQ detects this and automatically suppresses their intensity, preventing coordination collapse. This system hinges on using successor distance as the intrinsic reward. Unlike entropy or random network distillation, successor distance measures temporal reachability between states, creating a quasi-metric structure that naturally separates agents based on how much their experience depends on teammates versus independent exploration. Tested across 7 cooperative benchmarks, this quality-aware allocation consistently achieves top-tier returns while eliminating the training collapses that plague fixed beta methods. It's a clean, information-theoretic approach that finally lets multi-agent teams explore smarter, not harder.